my dear students, welcome to Teacher at Home. Today class we are going to learn the first chapter, Seasons and Time. The wonders of seasonal change exhibited by the nature are varied. Winter is the season where everything is buried in snow. As the winter retreats, the grass and trees slowly turn green. The spring season arrives with leaves and flowers in different hues. Then summer sets in biting adieu to the reign of spring. Comes the long rainy season as a relief to the scorching summer, and then follows autumn. Trees start shedding their leaves within a few weeks in preparation to welcome the forthcoming winter. And the winter returns, months of severe cold then. Such astonishing visuals that the nature prepares are more pronounced in the mid latitudes. While it is noon at one place, it is midnight elsewhere. 2 different days, but at the same time on the earth, just like the wonders of the seasons, the sequence of time is also diverse. We have just read a brief note on the seasonal changes. We experience the recurrence of winter, summer, rainy seasons one after the other. Such a change on the earth is known as the seasonal change. Why seasons change? Variations in the amount of sunshine are the important special feature of the different seasons. Earth's revolution and the tilt of the axis are the reason for the variation. You know that it is an elliptical orbit that the Earth revolves around the Sun. It is known as revolution. You have learned in the previous class the axis of the Earth is tilted at an angle of 66.5 degrees from the orbital plane. If measured from the vertical plane, this would be 23.5 degrees. Earth maintains this tilt throughout the revolution, and it is known as parallelism of the Earth axis. Sun rays orbital plane, equator tropical of Capricorn, Antarctic circle, South Pole, Sun and Earth near and far. The distance between the Earth and the Sun will vary continuously throughout the period of one revolution. The days on which the Sun and the Earth are nearest and farthest are shown in the diagram. These days are known as perihelion and aphelion respectively. September 23rd, that is, axis is shown here. Observe the parallelism of the Earth axis from the diagram. Since the parallelism is maintained same throughout the revolution, the position of the Sun in relation to the Earth varies apparently between the Tropic of Cancer, Tropic of Capricorn. It is known as the apparent movement of the Sun. Apparent movement of the Sun due to the inclination of axis is the reason for the occurrence of seasons. Look at 4 different positions on the Earth during a single revolution 1 year around the Sun are depicted in it. There is variation in the sunlight that falls on the Earth due to the apparent movement of the Sun. Sun rays fall vertically over one hemisphere during one half of the year and the other hemisphere during the other half. Temperature will be higher over those places where the vertical rays of the Sun fall. Temperature will be low at place where the Sun's rays are slanting. Seasons and apparent movement of the Sun. As a result of the apparent movement of the Sun, between the Tropic of Cancer, 23.5 degrees north, Tropic of Capricorn, 23.5 degrees south, different seasons, spring, summer, autumn, and winter, get repeated in a cyclic manner. Seasonal changes are not usually very obvious in the tropical regions because of the incidence of large amount of sun rays throughout the year. Characteristics of different seasons are clearly felt in the mid-latitudinal or temperate zones. North Pole, Arctic Circle, Tropic of Cancer, Equator, Tropic of Capricorn, Antarctic Circle. Equal amount of sunlight is received in the northern hemisphere as well as in the southern hemisphere when the Sun is vertically above the equator. Apparent position of the Sun during the Earth's revolution will be over the equator on March 21st, September 23. and the length of the day and night will be equal during these days on both the hemispheres and are called equinoxes. From 21st March onwards, the sun apparently shifts from the equator northwards and reaches vertically over the Tropic of Cancer, 23.5° north on 21st June. This day it is known as the summer solstice in the northern hemisphere. On this day, the northern hemisphere experiences its longest day and shortest night. The northern hemisphere generally experiences spring season between 21st March and 21st June. Spring is the season of transition from winter to summer. Haven't you noticed the plants sprouting, mango trees blooming, and jackfruit trees bearing buds and bee like? These are the peculiarities of spring season. Identify the season, the southern hemisphere during this period. The southward apparent movement of the sun begins from 21st June and again reaches vertically above the equator on 22nd September. Summer season is experienced in the northern hemisphere during this period. The sun continues its southward apparent shift from the equator from 23rd September and reaches vertically above Tropic of Capricorn on 22nd December. This day is known as the winter solstice in the northern hemisphere. On this day, the northern hemisphere experiences shortest day and longest night. It is autumn season in the northern hemisphere from 23rd September to 22nd December. Autumn marks the transition from the severity of summer towards winter. During this period, atmospheric temperature decreases considerably. There is shortening of day and lengthening of night during the period. This is a season during which the trees gently shed their leaves. Shedding of leaves in the form of adaptation to survive the forthcoming dry winter. The northward apparently shift of the sun begins by 22nd December, again reaches vertically above the equator on 21st March. This period marked the winter season in the northern hemisphere, which will be the season in the southern hemisphere when it is winter in the northern hemisphere. Month from March 21st to June 21st. Apparent movement from the equator to Tropic of Cancer, northern hemisphere spring, southern hemisphere autumn. From 21st June to September 23, Tropic of Cancer to the equator, summer and winter. September 23 to December 22nd, from the equator to Tropic of Capricorn, autumn and spring. December 22 to March 21, Tropic of Cancer to the equator, winter and summer. Traditional seasons of India. Traditional seasons of India. Though the Indian seasons are generally classified into four, it is estimated that there are 6 seasons in India based on the changes in the atmospheric condition. Vasanta, March, April, Grishma, May, June, Varsha, July, August, Sharat, September, October, Hemanta, November, December, Sisira, January, February. Uttarayanam and Dakshinayanam. You might have understood the apparent movement of the sun and the resultant seasons in both the hemispheres. Following the winter solstice, the sun gets its northward apparent movement from Tropic of Capricorn, 23.5 degrees south, and it culminates on Tropic of Cancer, 23.5 degree north, on 21st June. This northward apparent movement of the sun from Tropic of Capricorn to Tropic of Cancer is termed as Uttarayanam. Duration of day in the northern hemisphere gradually increases during the period. Following the summer solstice, the sun gets its southward apparent movement from Tropic of Cancer, 23.5 degree north, and it culminates on Tropic of Capricorn, 23.5 degree south, on 22nd December. This southward apparent movement of the sun from the Tropic of Cancer to Tropic of Capricorn is termed as Dakshinayanam. During the period from March to September, as the sun is in the northern hemisphere, the North polar regions experience continuous daylight for 6 months. During the remaining period, that is from September to March, As the sun is in the southern hemisphere, the North Polar regions experience continuous night for 6 months. Rotation and calculation of time. I looked at the clock. It was showing 12. The air hostess announced that we should set all our watches back by 5.5 hours. As per our watches, it was 5:30 Indian Standard Time. One could say the aircraft was flying towards the west, literally swallowing our Indian Standard Time. We had to run, turn back the hands of our watches every now and then accordingly. Translated from S.K. Patekat's Padira Surinde Natil, in the land of midnight sun. Hope you read the extract from Padira Surinde Natil, the famous travelogue by the renowned author S.K. Patekat. Aren't you convinced? That is, convinced the time in other countries is different from the time in India. Let's examine the reason behind these differences. In the ancient period, time was calculated based on the apex position of the sun and the length of the shadow cast by it. When the sun is vertically overhead, it is noon. Thus, the time estimated at each place based on the position of the sun is termed as the local time. The midnight sun. The sun shines even at midnight, not for a single day, but for 6 months throughout, in the Arctic and Antarctic circles. But don't think the sun will be vertically overhead during those days. The sun can be seen only on the horizon. Remaining 6 months are shrouded in darkness. Daylight lasts only for 1 or 2 hours. The land will be covered with snow. Human life and limited agriculture here are scheduled according to the peculiarities of this climate. Later on, the calculation of time became more scientific and accurate. Let's go into details of time calculation. You know that the earth rotates on its axis while it revolves. You also have learned that day and night occurs due to rotation. Look at some of the facts associated with rotation. The earth rotates from west to east. Takes 24 hours to complete one rotation. As the earth rotates from west to east, the sun rises in the east. Angular distance of the earth is 360 degree. We'll get 360 latitude if we draw one longitude each for each degree of angular distance. Time required to complete a 360 degree rotation is 24 hours. On converting 24 hours into minutes, 24 into 60, that is 1440 minutes. That is, time required for the completion of one rotation is equal to 1440 minutes. Time required for the earth to complete the rotation and 1 degree longitude is 1440 by 360, it is 4 minutes. Time required for the rotation is 15 degree longitudinal area is 15 into 4, that is 60 minutes. That's equal to 1 hour. In other words, 15 degree longitudinal area of the earth passes by the sun within a period of 1 hour. 11:56 a.m. 1 degree west, 12 noon 0 degree, 12:04 p.m. 1 degree east. As the earth rotates from west to east, time advances towards the east and recedes towards the west. Look at the illustration. From a definite longitude, the time is estimated to increase by 4 minutes towards the east and decrease by 4 minutes toward the west for every degree of longitude. Greenwich time, GMT and time zones. The 0 degree longitude is known as the Greenwich meridian. It acquires its name from Greenwich, the place where the Royal British Observatory is situated, and through which the line passes. Time is calculated worldwide based on the Greenwich line. And this line is also known as the prime meridian. The local time at the prime meridian is known as the Greenwich Mean Time. Based on the Greenwich meridian, the world is divided into 24 zones, each with a time difference of 1 hour. These are known as time zones. Standard time. The local time would be different at each longitude. If you start calculating the local time at different places based on the longitude there, it would create a lot of confusion. To solve this, the local time at the longitude that passes through the middle of the country is selected as the common time for the whole country. Each country in the world considers the longitude and passes almost through its middle at the standard meridian. A country with large longitudinal extent estimates more than one local time by considering more than one standard meridian. Local time at the standard meridian is the standard time of that country. Indian Standard Time. The longitudinal extent of India is from 68 degree east to 67 degree east. The 82.5 degree east longitude, which passes almost through the middle of this longitude, had been fixed as the standard meridian of India. The local time along this longitude is generally considered as the standard time of India. It is known as the Indian Standard Time. International Date Line. Calculate the time at each 15 degree longitude east and west of the Greenwich line up to 180 degree longitude and complete the table. Time at Greenwich. Friday 10 am. To the west of Greenwich 15 degrees Friday 9 am. To the east of Greenwich longitude 15 degree day Friday time 11 am. You might have noticed that there is a difference of 24 hours at 180 degree longitude to the east and west of Greenwich. The place A marked in the green figure is located at 180 degrees longitude. Which day would it be to those residing at place A in figure? If 180 degree longitude passes through a country, the places situated east and west of all this line will be having two different days. Think about the practical difficulties caused by this. To avoid this, certain necessary adjustments have been effected in this line with the result that it does not pass through the corresponding land area. Note the longitude marked with broken lines. The line in such a way that it passes through Bering Strait in Pacific Ocean and avoids some of the inhabited islands. Travelers who cross the line from the west calculate the time by advancing it one day, and those who cross the line from the west detect one day. Imaginary line is known as the International Date Line. Let's calculate time. What will be the time in India when it is 12 o'clock at Greenwich? Let us see how the time of India is calculated. Longitudinal difference between India and Greenwich is 82 degree 30. Time difference for 15 degree longitude is 1 hour. Time difference for 82 degree 30 longitude, it is 5.5 hours, 5 hours 30 minutes. As India is located to the east of Greenwich, time in India will be 5 hours 30 minutes ahead of Greenwich Mean Time. Therefore, the time at India, time at Greenwich plus time difference, 12 noon plus 5 hours 30 minutes, 5:30 p.m. What will be the time in Japan, 135 degree east when it is 11 p.m. on Monday in India? 82 degree 30 minutes India, 135 degree east Japan. The longitudinal difference between India and Japan, 135 degree, 82 degree 30 minutes, 52 degree 30 minutes. Time difference for 1 degree longitude is 4 minutes. Time difference for 52 degree 30 is longitude is 52 and a half into 4, 210 minutes. 3 hours 30 minutes. As Japan is situated in the east of India, the time in Japan would be 3 hours 30 minutes ahead of that time in India. When it is 11 p.m. on Monday in India, the time in Japan is 11 p.m. Monday plus 3 hours 30 minutes, that is 2:30 a.m. Tuesday. So in Japan it is 3 hours 30 minutes. So that's all about this chapter. If you are interested, please do like, share and subscribe my channel. Okay, thank you.